Okay, so now we've talked about the distance formula, and now what we're going to look at is what is the distance formula? How do we get it? How do we derive the distance formula? Where does it come from? This obviously has a purpose. And what we want to avoid when we're in geometry and algebra is being robots and just plugging into formulas and plugging in values and not knowing exactly what we're doing. So I'm going to explain here where the distance formula comes from, and I think you'll recognize the origins of it. So when we look here, this is our distance formula. The distance equals the difference between the two x's squared plus the difference between the two y coordinates squared and the square root of that value. Okay? And the x2, y2, and the x1, y1 are your 2 points. So for this example, we're looking at the coordinate plane. I have points A and B. And for A and B, I want to find the distance. So this is the distance right here from A to B. We want to find that distance, and we've been using this formula. So the question is, why do we use that formula? What is the basis of that formula? What's the origin of that formula? Well, it's actually something that you've seen before. So what I'm going to do, A is at negative 2, and B is at 4, 3. So what I'm going to do is I'm going to find the distance first using the distance formula, the same old way that we've done it. All right, so off to the side here, let's find the distance. We'll take the square root and remember, with distance we're dealing with differences. Remember, with midpoint we're dealing with sums. We add. Distance is difference. Okay, so now I'm going to plug in my 2 points, and I've got negative 2 and 4 are my 2 x coordinates, and my 2 y coordinates are negative 2 and 3. Now, to save us some time, I'm going to kind of skip some steps here. To work this out and actually find the distance, if I were to work this out, negative 2 minus 4 is negative 6. When I square negative 6, I get 36. Negative 2 minus 3 is negative 5. When I square negative 5, I get 25. And that will come out with a distance of 36 plus 25, which is 61. So the square root is 61. The square root of 61. Now 61 is a prime number. That's something that that does not have any factorable values. There's nothing that we can factor into 61 besides 61 and 1. So that's your distance. So that's how we've been doing it. So the question is, why does that work? Well, we're going to take another approach. So let's look at the same picture and let's ignore this distance formula that we've just done. I'm going to approach this using a geometric figure. So what I'm going to do is I'm going to draw a vertical line from B all the way down until I'm even with A. So that's going to be my vertical line right there. Okay? And then I'm going to come across here and I'm going to draw a horizontal line from A all the way till it's even with B. Now, when you have a completely horizontal and a completely vertical line intersecting, they're going to form a right angle. They're perpendicular. And if you'll recognize this, we now have what we call a right triangle. Okay? And for right triangles, you remember we have A and we have B to represent our side lengths, and we have C, which is where I have my distance. So we're going to use the Pythagorean Theorem. Now, the Pythagorean Theorem, which we've seen and had ingrained into our brain, the Pythagorean Theorem is a squared plus b squared equals c squared. Okay? And we know that that's when you have a right triangle. The sum of the squares of the two sides equals the square of the hypotenuse. Now that has to do with the areas of squares that you are able to draw on each side, but we'll get to that a little bit later down the road. So we're going to take this Pythagorean theorem. So how would I find the length of A? How do I find the length A? A is this length right here. Well, in order to find that length, I'm going from this one to this point. that point to that point. So that's my horizontal distance. This point is at -2. This point right here is at 4. So I'm going from -2 to 4. So what I'm going to do to find that distance is I'm going from -2 to 4. I'm going to subtract it. Isn't that how we find distance? We do the subtraction. So -2 to 4. Now that's going to end up being -6 or 6 units, but we're going to end up squaring it anyway. So that's how we find our A value, and that's A squared. So now let's look at our B value. Our B value is going to be our vertical side right here. For my B value, I'm starting at -2, and I'm going up to 3. So that's going to be plus -2 minus 3. And that's going to give us B squared. For our C value, which is our distance, we don't have anything that we can count. It's not a horizontal or vertical distance. It's actually slanted, or it's got a positive or a negative slope. So it's not something that we can just count like we did here. With horizontal and vertical, you can count to get the distance. We could have also counted across, but I want to show you where the distance formula comes from. So look at your distance formula carefully. Let's look at it again. Now I know that A squared, this is my A length, that's A squared plus B squared is going to equal C squared. This is how I get A, this is how I get B. And remember, it doesn't matter either way whether it's negative or positive, because what do we do in distance anyway? We take the absolute value. And here you're squaring it anyway. So -2 minus 4 squared plus -2 minus 3 squared. That's your A distance squared, your B distance squared equals C squared. But I don't want C squared, I just want C. So I'm going to square root both sides. When I take the square root of both sides, I'm going to end up with C on this side, and the square root of the difference of the two x coordinates squared, which is your A, plus the difference of your two y coordinates squared, which is your B, equals C. Look at the similarity between this formula in this setup and your distance formula. It's the same thing. So the distance formula is actually derived from the Pythagorean theorem. So we use the Pythagorean theorem to find the distance. Now again, you would have gotten -6 here, but remember distance is always positive, so we would have absolute valued this and made it a positive.